In this lecture, we will focus on chemistry. During the lecture, try to answer the following questions. Why does a sand dune and a single grain of sand contain about 125 million trillion atoms? Are atoms made of molecules or are molecules made of atoms? The term element is used when referring to macroscopic or submicroscopic. The term atom is used when referring to macroscopic or submicroscopic. Chemistry is often called the central science or material science because it's found in almost every scientific subject. For example, biology, physics, and even engineering all involve chemistry. Like all subjects, there's an upside and downside to chemistry. Read or listen to the following articles and determine for yourself. Is it truly better living through chemistry? Physical property describes the look and feel of a substance, while chemical property describes the characteristics of a substance. These characteristics are typically determined at the atomic level. For example, when your hair turns gray, it bleaches itself. This may seem like a physical property, but it's not, because graying is a chemical process and a part of the hair's identity. Here are some examples of physical properties. Please make sure you are able to identify what's a physical property. Do not worry about knowing the differences between intensive and extensive properties. Please make sure you understand what's a chemical property. Do not worry too much about the details behind enthalpy or coordination number. A substance is identified not only by the kinds of atoms it contains, but also by how these atoms are connected to one another. A physical change imposes a new set of conditions on the same material. A chemical change forms a new material with its own unique set of physical properties. Both physical and chemical changes result in a change in physical appearance. This is a very important slide. That's all I'm going to say. Here's another important slide. Study it. Now let's talk about the differences between elements, molecules, and compounds. Elements are comprised of one type of atom. If you notice, the oxygen molecules have more than one atom. This is because oxygen is a diatomic molecule in nature. However, water is a compound comprised of two hydrogens and one oxygen. This slide illustrates the differences between elements, molecules, compounds, and mixtures. Are all molecules compounds? Are all compounds molecules? You tell me. Now test your understanding and check your answer. To name compounds, we must learn the prefixes. On the slide, I have listed the first 8, but I would learn at least the first 10. Then we identify whether the first element in the compound is a metal or a nonmetal. For metals, write the elemental name. Example, sodium. For nonmetals, add the prefix unless it's mono and write the elemental name. Example, dihydrogen. Then we name the second element and drop the ending and add the suffix IDE. Please familiarize yourself with the naming system and practice naming different compounds. Chemical reactions occur when chemical changes occur. Atoms are rearranged and chemical bonds are broken and reformed. One or more substances change to produce one or more different substances. In this course, we will focus on these 4 types of reactions: synthesis, which is creating, decomposition, which is separating, combustion, which is burning, displacement or replacement, which is switching. We will come back to this later and discuss the details of each reaction, but for now we are going to focus on balancing chemical equations. Spend some time analyzing the format of a chemical equation, then move on to the next slide. There are practice problems in Notes 3. During a chemical reaction, one or more new compounds are formed as a result of the rearrangement of atoms. No atoms are gained or lost in any reaction. Watch the video and take notes. Again, in a chemical reaction, atoms are neither created nor destroyed. In other words, all atoms present in the reactants are also present in the products. Chemical equations must account for and show the conservation of mass. This is why we must balance equations.